Visualizing the space Jacobian for 5-hour planar robot using the theory, and this theory is used in computer software. In our previous video we have discussed the geometrical point of view, but now we are applying theory. This one of 5-hour planar robot, first joint, second joint, third, fourth, fifth, and we want to find JS3 of theta. That is, after applying theta 1 and theta 2, if we rotate the frame at joint 3, that is theta 3 dot only, what is the Vs of this point? That is, if we consider body origin here, so here we have first applied theta 2, joint 2 is rotated up to theta 2, we have taken 60 degree. So this pose, and then after, this is S dash frame, this is S frame. Then after we have rotated this one also, theta 1, which is 30 degree. Keeping all joints are same. So already 60 and then after 30, so this frame becomes vertical, exactly same. See, observe the figure, theta 1 is 30 degree, this theta 1 30, this theta 2 is 60 degree. So home frame is this S, this frame X dash, this Y dash, and then after this frame S double dash, this is S double dash. We want to find JS3 of theta, and the formula is the ith column of JSI of theta is adjoint representation of e raised to s1 theta 1 dot 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 e raised to si minus 1 theta e minus 1 into si. This is the formula. So JS3 of theta, according to this formula, adjoint representation of e raised to s1 theta 1 into e raised to s2 theta 2 into s3. S1, S2, S3 are screw axis. For this S3, S1, S2, S3, this S1, S2, S3 defined for home frame only, 0 frame. So consider this point. If we rotate this way, and if we consider body origin here, then what about its velocity? Of course, if we rotate this, body velocity in this direction, so it has y component only and it is negative. But this one is 1 and 2, so minus 2. Because of omega we have taken 1. So from home frame, S3 is omega 3 V3, omega is 0, 0, 1, X, Y, and this one is Z axis, so 0, 0, 1. And V3 is 0, minus 2, 0. This one, S1, S2, S3 always depend on for 0 frame. How we can achieve this theoretically? So V3 is omega 3 cross minus Q3. This one. This is origin, this is Q3 here, this to this vector. But we have put opposite direction, so this one is from this to this arrow is here, minus Q3. So minus of omega 3 cross Q3. Omega 3 is 0, 0, 1 and Q3 is 2, 0, 0. If you take cross product and minus sign, we will get this one. Now, e raised to s theta, we have a formula. E raised to omega theta, here I theta plus 1 minus cos theta omega plus theta minus sin theta omega square, skew symmetric square, into V. V is Vs, velocity of body expressed in S frame. Here 0, 1. So using this formula, using above formula, we get e raised to s1 theta 1. This one is rotation matrix, and we have formula for this. This is the formula. Rotation matrix, e raised to omega theta equal to I plus sin theta omega plus 1 minus cos theta omega square. If you put all such values, we get rotation matrix. So this one is rotation matrix, and this one is translation vector P, RP01. So if you put all such values for theta 1, we get e raised to s1 theta 1 is this matrix, root 3 by 2 minus half 0, 0, half, root 3 by 2, 0, 0, 0, 0, 1, 0, 0, 0, 0, 1. Using this, you can obtain this. And e raised to s2 theta 2. So theta 2 is 60 degree, and S2 we have already defined this one. Using this formula we get half minus root 3 by 2 0 half root 3 by 2 half 0 minus root 3 by 2 0 0 1 0 triple 0 1, and we want product of these two. So e raised to s1 theta 1 into e raised to s2 theta, because we require this one adjoint representation of this matrix. So we have obtained this one e raised to s1 theta 1 into e raised to s2 theta 2. If you multiply these two, you can check, cross check whether I have made mistake or not. So you will get, after multiplying this and this matrix, you will get 0 minus 1 0 root 3 by 2 1 0 0 minus half 0 0 1 0 0 0 0 1 RP01. This one is rotation matrix, and this one is translation vector, that is, and P is, from this P is root 3 by 2 minus half 0. So skew symmetric of P is, according to definition, 0 0 minus half 0 0 minus root 3 by 2 half root 3 by 2 0, for the definition of skew symmetric. And R is this one 3 cross 3. So we require product of these two. So I have multiplied these two matrix here. The final result, that is skew symmetric P into R, 0 0 minus half 0 0 minus root 3 by 2 root 3 by 2 minus half 0. You can cross check or multiply yourself. This is skew symmetric PR. Because of this one, we require this, because we know that adjoint representation of transform matrix is R0 PRR. So we have obtained this. Okay. So adjoint representation of transform matrix is R0 PRR, and we want to find JS3. It is adjoint representation of this one into S3. So adjoint representation of this one, it is a transform matrix, and we have obtained already this product of this. So this is R, 0 minus 1 0 0 1 0 0 0 0 1. This is R. This one is 0. P into R we have obtained, so I have put here. And R again, this one, 0 minus 1 0 1 0 0 0 0 1. And S3 is screw axis, we have discussed already. So 0 0 1 0 minus 2 0. If you multiply this and this, we get this and this, we get this. So 0 0 1 3 by 2 minus root 3 by 2 0. This is V3 and this is omega 3, and this is exactly equals to our geometrical result. Note, e raised to omega theta is rotation matrix, and it is I plus identity matrix plus psi theta into omega plus 1 minus cos theta into omega square, where omega is unit vector, axis of rotation vector. Using this we can find the corresponding rotation matrix. From home frame, S1 is 0 0 1 0 0 0 because of body frame and space frame coincides, so no velocity is there. And S2 is 0 0 1 0 minus 1 0. Now we will find P2 for e raised to S2 theta 2. This one. For this here RP01, this one. But for this matrix, because this is a well defined rotation matrix, so we want this term. So here this term is I theta plus 1 minus cos theta omega plus theta minus sin theta omega square into V1. This one is V2. So for theta 2 is pi by 3, I is 1 0 0 0 1 0 0 0 1. 1 minus cos theta, 1 minus cos 60, so 1 minus half. Omega we have calculated because omega is well defined 0 0 1. It is skew symmetric of this. And theta is pi by 3 minus root 3 by 2 because of sin 60 is root 3 by 2. Omega square, that is this matrix into this matrix. So I have calculated and put it here, minus 1 0 0 0 minus 1 0 0 0 0. So and this one into V1, sorry V2, but here there is no space, so consider this one whole into V2. This one is pi by 3 0 0 0 pi by 3 0 0 0 pi by 3. This one is 1 minus half is half. So 0 minus half 0, half 0 0 0 0 0. And this one is minus sign here. So minus pi by 3 plus root 3 by 2 0 0 0 minus pi by 3 plus root 3 by 2 0 0 0 0. Now corresponding elements are added. This one plus this one plus this one. This one is root 3 by 2. This plus this is minus half. This plus this is 0. This plus this is half. This middle term, this plus this is root 3 by 2. And 0 0 plus 0 plus 0 is 0. And this 0 plus 0 plus 0 is 0. 0 plus 0 plus 0 is 0. Pi by 3. This one pi by 3 plus 0 plus 0 is pi by 3. And this into this 0 minus 1 0. If you multiply this into this 0 minus 1 half into minus 1 so plus half. This into 0 minus root 3 by 2 0 and then after 0. This is P2. See here S2 theta 2. So half minus root 3 by 2 0. This one. This is rotation matrix. It is well defined. So I am not calculating. Using this we can find rotation matrix. So see this column half minus root 3 by 2 0. It is also half minus root 3 by 2 0. And for this S1 theta 1. But S1 coincides with space frame. So V1 is 0. So P1 is automatically becomes 0. So we don't require this calculation. This one 0 0 0.